Here we're going to look at the Vedic method for algebraic division, which, once you get the hang of it, is very much easier and faster than the conventional method of long division. The relevant sutra here is transpose and adjust, and this sutra has very many applications. In Sanskrit it is para-vartya, yojayet, yet. Para-vartya yojayet. First of all, I'm going to show how this method works in arithmetic, and this can give some understanding of how it works. Suppose we have to divide 52 into 107, and we're going to have a remainder section, and all we need to do here is divide, rather than divide 50 into 100, we could divide 5 into 10, which gives 2. We transpose this digit, this ones digit, to a minus number, just change the sign, and then on multiplying 2 times minus 2 we get minus 4, and that is written in the remainder section. And then for the remainder we add up. 7 add minus 4 is 3. Now the advantages of this won't really become apparent until I get on to the algebraic division. But let's suppose that we have to multiply 48 into the same number, 107 divided by 48. I can write this as 107 divided by 50 less 2. And so here we would have the 48 is 50 bar 2 divided into 107. We change the sign of this minus number to plus 2, and then proceed as before. 5 into 10 is 2, and then 2 times 2 is 4, which is written here in the remainder section, and we simply add up for the remainder to remainder 11. And this, so in conventional long division, algebraic division, both algebraic and numerical, we subtract these remainders, but in the Vedic system we add, which is actually easier to do. Now moving on to a simple example, getting a piece of paper here. Suppose we have to divide x plus 3 into x squared plus 10x plus 21. We transpose this plus 3 and becomes a minus 3. And all we do is divide by the x and then adjust accordingly. So we say x into x squared goes x times. We then multiply this x by the minus 3 to give minus 3x and write it in the next column. We then add up this second column, giving 7x, and divide by x, giving plus 7. And now we've got down to the numbers here, so everything else is going to be a remainder, and 7 times minus 3 is minus 21, and we can add up for the remainder 0. Here's another example, x minus 2 divided into x squared minus 7x plus 1. Again, we transpose the minus 2 to a plus 2. X into x squared goes x times. 2 times x is plus 2x. We add up this column and divide by x, so it gives minus 5. And then multiply 2 times minus 5 is minus 10, and add up for the remainder, minus 9. Well, let's extend this to dividing a binomial into a cubic. Suppose we have x plus 1 into x cubed plus 2x squared plus 5x minus 1. Transpose the 1, x into x cubed goes x squared times. And multiply here, minus 1 times x squared is minus 1x squared. And then add up and divide by x, and we get 1x squared divided by x is plus 1x. 1 times minus 1 is minus 1x. Add up and divide by x is plus 4. 4 times minus 1 is minus 4. You simply add up for the remainder, minus 5. Now, one further aspect is that you will see here that the powers of x are decreasing by 1 with each column. So here we have x to the power of 3, 2, 1, x to the power of 0. Given that we know which column we're in, we don't actually need to bother with writing all this. And so this division, I'll just do the same one, but without so much writing, because we just need to deal with the coefficients. X into x cubed goes x squared times. It was 1 times minus 1 is minus 1. It's really minus 1x squared, but knowing that we're in the x squared column, we don't really need to write it because we're just dealing with the coefficients. 2 add minus 1 is 1. So it's 1x squared divided by x is plus 1x. 1 times minus 1 is minus 1. Again, I don't write this x. We just add up and divide by x gives plus 4. And then we have the remainder as before. Now suppose that in all these cases, just the divisor here is x. What happens if we've got 2x or 3x? So the next example shows this. We'll divide 2x, add 3 into 4x cubed plus 7x plus 4. And since there's no x squared term, we'll just add in 0x squared here. Transpose the plus 3 to a minus 3, and then we divide 2x into 4x cubed goes 2x squared times. 2 times minus 3 is minus 6, again only using the coefficients. 0 add minus 6 is minus 6. X squared divided by 2x is minus 3x. Minus 3 times minus 3 is plus 9. That's 16x divided by 2x is plus 8. 8 times minus 3 is minus 24. Add up for the remainder, minus 20. Well, we're not limited to just dividing by binomials. We can divide by polynomials of any size. So in this next example, I'm going to divide by x squared plus 2x minus 1 into x to the power of 4 minus 3x squared cubed plus 1x squared plus 17x minus 1. A bit more space needed here. Here we transpose all the terms except for the initial one, so this becomes a minus 2x and this becomes a plus 1. And proceed as before. X squared into x to the power of 4 is x squared. That's 1x squared. Multiplied by minus 2 and plus 1 gives minus 2 here and plus 1 here. So we write those two products into the next two columns. Then we add up. Here we get minus 5x cubed divided by x squared is minus 5x. Again, with the just using the coefficients, minus 5 times minus 2 is plus 10. And minus 5 times plus 1 is minus 5. We add up and divide by x squared. So we have 1 plus 1 plus 10 is 12. X squared divided by x squared is plus 12. And now we're down to just numbers here, so we've got to the end. We just need to calculate the remainder. Plus 12 times minus 2x is minus 24x, so we'll just write minus 24 here. Again, we're in the column for x. And 12 times 1 is 12. So now all we need to do is add up for the remainder, and that comes to minus 12x plus 11. And that's it. So that is an introduction to algebraic division, Vedic style, and it does take practice, but once you get the hang of it, it's very quick and easy. The following video is going to show how this method of division can be used to produce power series, and also to answer very easily A-level exam questions involving algebraic fractions.